Accessories, that's going to be all of our P-Link stuff. So this is a, well, PFC, but this is what the AFC 100 or the AFC 50 are going to look like. You got your P-Link connection there. That is a 4-wire connection, and you got 1 amp to work with there. We're going to talk about shortly here how you can expand that 1 amp. It's 24 volts, obviously. Maximum wire length is 6,500 feet. There's a calculator on our website because you can't just blanket everything with 6,500 feet. Obviously, it depends on what you're hooking up at the end of that run. So it's basically just a voltage drop, but we do have a calculator on our website to help you figure that out. Fully supervised, power limited. The AFC 1000 has 2 connections. They're the same thing. They all work the same. But, you know, on the AFC 1000, both connections are 1 amp each. Excuse me. And that just gives you a way if you want to go east and west or something like that out of the panel. You've got 2 different hookups there. Let's look at some of the common modules here. RS-485 type communication, yeah, the P-Link is basically our RS-485 loop. The UD2000, that's your dialer card. So if you're not going to use IP reporting, if you're going to use phone lines or a cell dialer or a radio or something like that, you're going to add the UD2000 for that. And then we've got our 2 Class A cards. So the two small panels are going to use the CA6075, and the AFC 1000 is going to use the CA6500 for the Class A. This is the installation on the UD2000 card. There's this would be on the AFC 1000. There's kind of a little track there underneath the display. Slides up into that, put 1 screw up top, and then it comes with a little cord to plug in there on the bottom. Question here about network. So we have specific network cards that are out now, and we're doing a webinar on those Thursday. So there's cards for that. You don't just hook the panels up directly to one another, but we do have network cards. Come back Thursday if you want to learn about those. This is just what your phone line connections look like, your RJ31X. The UD2000 card comes with those 2 little cables there. You got a couple LEDs on the bottom, line 1, line 2 active, and then the COM there. The Class A card for the small panels, P-Link, SLC, and the next. I/O circuits are Class B only. These install on top of the board to the right of the display. So it comes with this little bracket, put that in, card goes right on top of it, and that's what Class A looks like. So instead of having an in-the-blind resistor there, you have a return wire back to the panel. Same thing for the P-Link, SLC, all the same thing there. Couple different enunciators. The only one you need to worry about is the RA6500R. It's the large display, and you can use that on any of the panels. So if you're using the small panel, you can still use the larger enunciator. It comes in 4 different colors: red, black, light gray, dark gray. And that's what the displays look like. So again, the only one you want to buy is the 6500R. It's a much better display, bigger, easier to deal with. And I think in most cases it's cheaper than the small one because nobody buys the small one. So RA6500R, that's your enunciator. Let's take a look at what that looks like. So you open it up, same key as the panel, take the enunciator out. There's all your mounting holes, so you can mount it on whatever you want. And then on the back here, you just got your 4-wire P-Link connection, 2 data, 2 power. Set your address on your dip switch there, and then you're good to go. LED 16 if you're using LED enunciators. The LED 16 just gives you 16 LEDs. You can program however you want. And then we got the PSN 1000, which is your smart power supply. We're just going to go to the next screen here because it's got its own slide. So up to 31 on any panel. We'll talk about that P-Link repeater in a second. And it's going to be a 10 amp power supply with 6 NAC circuits. You've also got 2 dry contact inputs on there. So, you know, maybe you forgot about a flow switch or something. Instead of having to add a module, you can just wire it directly to a PSN 1000 if you want. Class A or Class B, and then there's 2 different versions. There's the 1000, which is pictured there, and there's a 1000E, which is just a larger cabinet, which allows you to mount up to 6 stacker brackets, those are the brackets that all the P-Link cards come on. They're called stacker brackets. So you can mount up to 6 P-Link cards inside of your PSN 1000E cabinet. I don't think there's much price difference between the two, so I usually just recommend doing the 1000E every time. That way you've got the space to mount the cards if you need it somewhere down the road. And you can change the end-of-line resistor values on these smart power supplies too, just like you can on the panel. Cabinet installation, exactly the same as everything else. So indoors, climate-controlled area. That's the inside of the 1000. That's the inside of the 1000E. So it's the same exact power supply, just a different cabinet. The whole front door comes off of the 1000E just like it does on the AFC 1000 panel. The small panels, you can't remove the doors. So whether it's an AFC 50, AFC 100, standard PSN 1000, you can't take the doors off. Here's what the boards look like. On the left side there, you see a low AC and a treble contact. Don't worry about those. You don't have to monitor them. All you're going to be dealing with is the smart side of the board over here on the right. So let's take a look at that. We got the 2 dry contact inputs there, the 6 NAC circuits. If you're doing Class A, you're going to have 3 NAC circuits. So if you do Class A, 1 and 2 becomes NAC 1, 3 and 4 is NAC 2, 5 and 6 is NAC 3, basically. And they're rated at 3 amps each, just like the fire panel NACs. That is your P-Link repeater there, or isolated connection, whatever you want to call it. And let's talk about how you're going to use that. So on the far right here, that's your essentially your incoming P-Link. You're always going to have wires there. And then you can go directly back out from those terminals if you want. Or you can come out of the repeater side. What that's going to do is give you another full amp of power. And it's also going to isolate the P-Link. So a short on the repeater is not going to kill the P-Link for the whole building. So it's a good thing to use. You know, whatever makes sense for how your system is laid out, you want to use those repeaters as much as you can. It just makes things a little more stable. Again, it gives you another full amp of power there. So don't forget about the repeater. Use those to your advantage. On to the MC1000 card here. So this one is, it strictly applies to reporting purposes. And what it allows you to do is to report multiple panel signals through one panel's dialer. So if you, let's say you got an apartment building or an apartment complex, you got a main panel in the clubhouse and you got a separate panel in each one of the little apartment buildings. Instead of having a dialer on each one of those separate buildings, you can put MC1000 cards in and you can just have all the panels report through the clubhouse panel's dialer. So it's not a this is not the network card. There's no control between panels. It's strictly for reporting purposes. So you can have 2 clients hooked up to each card, up to 31 cards, which gives you a total of 63 panels that you can hook up this way. And then the main thing is on the reporting side. If you're going to use the MC1000, you really should do CO reporting, because that's the only way you're going to get the actual point information to the central station. If you use the MC1000 cards and you're doing contact ID reporting, all you're going to get is alarm on building 2, trouble on building 5. You're not going to get the point information. So if you're going to use the MC1000, you definitely want to try to use CO reporting if you can. That's what it looks like. Host on the left side, your 2 clients on the right. And that's what the signals will look like. So the host panel does show the signals from the other panels, but it doesn't get specific. So it's just going to say, like it shows here, apartment building 1, there's a fire alarm. You go to apartment building 1, take care of it there, and then it'll clear off of the host panel on its own. And again, there's no control here. So if I did a silence and a reset from this host panel, apartment building 1's panel is not going to change at all. You can't control that. You have to go to that specific panel, take care of the problem there, then it'll clear off the host panel on its own. And this is just all just what different ones look like. So there's a water flow, supervisory, trouble, whatever. They all look the same. On to some more cards here. We already talked about the SLCE. That's the loop adder card for the AFC 1000. 127 points each. The DRV50, that's your 50 LED driver card. So if you're doing smoke control, which really you'd have to use an IPA panel for that, but this is your LED card for it. Or if you're doing like a graphic annunciator, just gives you 50 LEDs and you can map them however you want in your program. Oops. Then you got the Relay 5 card, which is just 5 relays that you can program however you need to. So the nice thing about it is it's 5 individual relays, but they're on the P-Link, so they don't affect your SLC loop at all. So if you're just running short on SLC space and you need some relays, you don't want to install the relay modules because you don't have that much room left on your SLC, you can use the Relay 5. The other common use for this is for elevator recall. Instead of having 4 to 5 separate relay modules mounted on the wall, you can just put one Relay 5 card in. And this, we have a small cabinet that you can put it inside of, and it just makes it a little bit of a cleaner setup. The IDC6, this is the one I mentioned before that you could use instead of the zone module. This one gives you 6 input circuits, and it is compatible with 2-wire smokes. So instead of having 6 separate zone modules, you can just put one of these in, and now you got 6 zones you can monitor there. Or even if you just wanted to use it for a bank of flow switches or something like that. Just 6 inputs here. The FCB1000 is a remotely located Ethernet connection. Don't worry about that one too much. It's not commonly used. We got the fiber card here, the FIB1000. So it's going to convert your P-Link into fiber. So if you're going, maybe you're doing the MC1000 scenario, and you're going to monitor your apartment complex, and you need to get P-Link around that complex somehow. Maybe you want to use fiber because of lightning issues. This is your card for that. So the thing to remember about this fiber card, the main thing is that it's not an in and out type of card. It's 2 cards for every fiber run. So if you're going from building 1 to 2, and then from 2 to 3, there's going to be 2 cards in building 2, because you got to have 1 card to bring the fiber in, you got to have another card to take it back out. So you can't go in and out of the same card with this fiber. So keep that in mind. 2 cards for every fiber run. And then the last one here, that's multi-mode fiber, by the way, with ST connectors. And then the last one here is your printer card. If you need to hook up to a printer, SPG 1000, there's your printer card. These last 3 are also available in a rack mount version if that works out better for your site. That's what it looks like. Same little card, it's just inside of a big, the 19-inch rack mount enclosure. Mentioned this before, all the P-Link stuff, with the exception of the ones that install directly on the board, all the rest of them come on these stacker brackets. Depending on where you put those, you can stack them up to 3 high. So in the AFC 1000 or the PSN 1000E, you can put up to 6 cards in there, 3 high, side by side. And then we've got these 3 cabinets just for mounting P-Link cards. You got the 14 on the left, 8, and then the 2 on the right. So that 2 is kind of the one that gets used for the elevator recall stuff. You put the little AE2 can up, you put a Relay 5 card inside of it, and now you got a little elevator recall enclosure there. P-Link addressing. It's going to be dip switches just like the SLC. It's a little bit different though because you can have matching addresses as long as it's different types of P-Link devices. So every P-Link device can be addressed 1 through 31, and then you could have matching. So you could have an annunciator, a smart power supply, and a relay card, all at address 1, and that's perfectly fine. As long as they're different types of P-Link devices, they can share an address. When you start adding multiples of the same type of card, that's whenever you got to start counting up on your addressing. All right, let's take a look at the output options. So just a recap here, AFC 50 and the ARC and AFC 100 both have 5 amps and 4 total outputs, 2 NACs, 2 IOs. The AFC 1000 has 10 amps with 10 total outputs, 6 NACs, 4 IOs. And then you got the smart power supply, PSN 1000, which has 10 amps, 6 NACs. Supervised, regulated, reverse polarity, all the normal stuff. And then here's your options. So a NAC general purpose is just a standard 24 volts. Maybe you just need to run a water flow bell, something like that, where you don't need a sink or anything. You just use the general purpose option. That's also what you'll use if you're doing 4-wire horn strobes. You'll use general purpose for the NAC side, or the horn side, excuse me. 2 different aux powers, constant or resettable. Just like they sound, resettable resets when you reset the panel. And then you got 2 different door holder options, standard and low AC drop. The low AC drop just kills the door holder circuit if the panel loses AC power. And that's just to save on your battery size. Then you've got an aux ANSI, which is constantly pulsing temporal 3. City tie, if you're still doing city tie circuits, we've got an option for it there. We're going to talk about those sync circuits here in a second. Aux sounder base power, don't forget that's an option. If you're doing sounder bases, don't just call the power circuit aux constant or resettable or something like that. Make sure you do aux sounder base power. That's how the panel knows it needs to put a pattern on there. And then you got your release solenoid option. Then just kind of a recap here. 1 amp on the IOs, 3 amps on the NACs, 5.1K is your default end-of-line resistor, and you can change that anywhere between 2 and 27K. Output sync. These are the 4 manufacturers that we can provide a sync for: AMSECO, Wheelock, Gentex, or System Sensor. We can also sync all those together. So if your system was hooked up just like this one, different manufacturer on each circuit. I don't know why it would be, but if it was, they would all sync up together. Strobe wise, the horn on Wheelock's a little bit off from everybody else, so the horn wouldn't necessarily be in sync, but the strobes will all sync up just fine. That's just an example of Class B versus Class A here. So Class B, of course, has the inline resistor. Class A has the return back to the panel. And then all we're really trying to say with this slide is you can do whatever you want on the NACs. You can set them up however you need to. They can be, a couple of them are aux power, one's a door holder, one's sync circuit. You can set these up however you want. You're not limited there. Your only limitations are 3 amps per circuit or 10 amps total. So other than that, you can make them all aux power if you wanted to. Whatever you got to do for your system. Same thing on the I/O circuits. The only difference here is one of these could be monitoring a flow switch if you wanted it to. Here's your PSN 1000. So you can see there, if you're going to do Class A, 5 and 6 is one Class A circuit. So that's what that looks like. Return it back to the top. Same options on the PSN 1000. All the options you have on the panel itself, you have the same options for the NAC circuits on the PSN 1000. And then system-wide quadra-sync, you don't have to run any kind of special sync circuit or anything like that. The whole system is going to sync up on its own. As long as you're setting each circuit correctly for Gentex or system sensor or whatever, the system's all going to sync up just by default, and that's all just through the P-Link. Let's take a look at the input options. So these are going to be all the options you have for your input modules. So your SIM, your DIM, mini module, all that stuff. You got all the standard options here: pull station, water flow, trouble monitor, fire, just a general fire alarm. Then you've got your disable options there: inputs, outputs, or both. 2 different CO options: alarm or supervisory. The HVAC restart, that's just for that New York City thing, which I think is also a Miami thing. And then we've got these alert points here. So these last 4 are kind of functions that aren't fire alarm related, but maybe you want to just do it with the fire panel because it's there. So you've got a medical alert. Maybe there's a nurse call system and you just want to monitor that and activate a strobe or something when the nurse call is active. You can do the medical alert for that. Tornado alert or weather alert. If you're trying to activate some of those blue strobes for weather emergencies, you can use this for that. A lot of times weather radios will have a set of contacts you can monitor. So you could monitor that set of contacts and activate a weather alert. Process alert, just kind of a utility here. Maybe you're doing a CO detection system in a parking garage, but all you're really trying to do is activate some exhaust fans when the CO detector is activated in the garage. You don't really want to evacuate the building. You don't necessarily need to call the fire department. You just want to turn on the exhaust fans. So you can use a process alert for that. And then you got a security alert. Maybe they just want to add a panic button or something somewhere. Use security alert for that. So those 4 points are alert points. Whenever they go active, you don't get your alarm LED, your supervisory. They're a totally separate type of point. Those 2 inputs on the PSN 1000 have all the same options as the modules or the IOs do. And then this is your limitation. So an input circuit, no matter if it's a module, an IO circuit, inputs on the PSN 1000, it's 100 ohms or 10,000 feet. That's your limitations. And then, of course, all the inputs are 5.1K end-of-line resistor. You cannot change the end-of-line resistor value on inputs, only on the NACs.